So in video tutorial 2 we'll be covering Sketcher workbench in CATIA V5. CATIA V5. We'll cover 4 toolbars in our tutorial in detail. These toolbars are, first we're gonna take is profile toolbar, second is sketch tools toolbar, operation toolbar, and finally the fourth one is constraint toolbar. Now let's launch the CATIA V5. Let's see these toolbars in detail. So first thing we're gonna cover is the profile toolbar. Here we'll be having some command on this profile toolbar, which are, we have following tools and profile toolbars in profile toolbar. So first the command profile is profile. First command is profile, second is rectangle, oriented rectangle. Next we're gonna cover is parallelogram, then elongated whole, cylindrical elongated whole, keyhole, profile, hexagon, and then centered rectangle. Next we're gonna cover is centered parallelogram. Then we are going to cover is spline, connect, and next command is ellipse, parabola by focus, then hyperbola by focus, conic. In the final section we have line, infinite line, bitangent line, then we have bisecting lines, then line normal to curve, and axis, how to define axis, then point by clicking, and point by using coordinates, then equidistant points and intersection points, then projection point. So these are the major commands which we are going to cover in this profile toolbar. Now let's have a look in details in CATIA V5 in all of these tools, and launch CATIA V5. So here we have the CATIA. Now let's launch this, and here we are on Sketcher. Let's go to workbench of Sketcher and give it a name like tutorial 2. Press OK button. Make sure that we have enabled this hybrid design and click on OK button. Here we are in the workbench. let's have a sketch on front plane, that is YZ plane. Now let's take a sketch on the YZ plane, and here we are having a profile toolbar, in which first is profile. Click on the profile command to create a continuous polygon. So profile is a continuous type of polygon which is completed when it is connected to an endpoint. As you can see, I'm going to try. Profile command requires endpoint to be coincident to other point. So basically profile command completes when this is connected to other endpoint. Now next is the rectangle. Rectangle creates corner to corner rectangle. So it was my first corner and then the second corner. Now our rectangle has been created. In the rectangle section, next is our 3-point rectangle or oriented rectangle. Requires 3 points to be defined. First point, then second point, and then third point. And now my rectangle is defined by 3 points only, first, second, and third. As you can see here, these constraints are added of parallelism. Next is our parallelogram. Parallelogram also requires 3 points to be defined, first, second, and then third point. As you can see here, both of the front sides are parallel to each other. 4 sides are parallel to each other. So this is my parallelogram. Next is elongated whole. So elongated whole allows users to create straight slots, like we can make a straight slots like this inside any material or outside any region. Radius of end arc can be varied by double clicking. Just double click on the on the constraint and you can vary the radius of these ends of slot. Next is cylindrical elongated hole or slot. So you can just define a center point, then define the starting point, and finally the end points for curvature projection, and then thickness, which is the radius of this slot. Just double click on the radius and you can change the value either from radius to diameter or diameter to radius, which whatsoever you want to define. And here we have a cylindrical elongated hole. We have 3 curvatures: addendum, dedendum, and pitch circle. Next is keyhole. Keyhole profile is used to create object having keyhole shape. Just click on the first point, then second point for the length of the keyhole, third is the width of cylindrical section, and then finally circular section. So you can vary the radius of the circular section just by double clicking on this, and let's give it a value of 17. Also we can see here it's 6.34, so we can change it to 7. Here we have a keyhole created, as you can see here. Next is our hexagon. Hexagon is a regular polygon having 6 identical edges, as we know. Just click on the center where you would want to define this hexagon and click on anywhere in the point to define the circumferential radius of this hexagon, and your hexagon has been created. To define it, you can just give a constraint to a circle. Let's give it a value of 25 radius. So our hexagon or regular polygon has been fully defined. Next is our centered rectangle, which is driven uniformly by its diagonal. You can just click on a center point, and as you can see, it's being elongated on bidirectional or in each of the sides uniformly. You can just define each side by 40, let's say, and let's give a constraint on the other side to be 40 again. So my rectangle which is the centered rectangle, is fully defined. Now let's create the pair of 2 sides and have a centered parallelogram, which automatically deducts the intersection point to be center of this parallelogram. So we chose these two lines, and center was automatically selected, and now you can see it, our parallelogram has been created here. Next is the circular section. First is circle. Circle requires, as you know, is the center point and then the radius. So just click on the center point and define the radius of curvature, or the area where you want to define it, and just give a radial constraint. Just double click on it, and you can anytime modify the constraint just by double clicking on that one. You can also vary the value in the form of radius or diameter. Switch. Next is 3-point circle. Just define a first point, second point, and the third point. So this is how a 3-point circle is made. You can define the radius of the circle. Just double click on this and give a value of 25, let's say. Now, as you can see, you can move it anywhere, and suppose if you want to coincident this center point to be on the origin point, so just define its horizontal distance to be 0, and of course let me zoom in. As you can see, it's not coincident to origin yet, so just give a vertical distance from the center point of the circle also to be equivalent to 0. Now, as you can see here, my circle is fully defined as it's shown by green color, and its center is coincident to origin. Next, we can define a circle by coordinates just by giving the horizontal and vertical value of the center point of a circle. Just give a horizontal value of 0 and vertical value of 0, and give a radius of 20 and press OK button. So this is a circle whose center point is at origin and the radius is 20, as you can see here. Next, what we can do is we can define this by giving horizontal value 10, 20 and 20. So we can see our center point of the circle has been shifted 10 and 20 in horizontal and vertical direction respectively, and its radius is 20. So all we can do is just by defining. And next, we define the coordinates by Cartesian. We can also define it by polar system. Give a radius and angle, and again the radius. The first radius is for the center location of the circle, which is 20 and having an angle of 45 from positive x-axis. Second radius is to define the radius of the circle itself. Let's make a triangle and try it by tangent circle. So just give a first tangent, second tangent and third tangent. So this is my circle which was tangent to all of these three sides of a triangle, which is a tritangent circle. Next is our 3-point arc. Just give first point, second point and third point. Make sure that your arc is always made in an anti-clockwise direction. And 3-point arc starting with limits, so it is first point, first ending point, second ending point, and then third the radius. So these were the two limits, and third we define the radius, unlike the 3-point type. Next is arc. In this type we'll defining the center and then starting point and then ending point, so that our arc is made. This is our arc. Next is spline. Spline is a random curve controlled by control points. So let's define the control points randomly on the space and press the escape button. Now, as you can see here, these are the control points. As I'm moving these control points, the shape of the curvature is moved itself. So this is a spline. Let's make a 2 spline and connect them by connect command. Connect command, just click on the first and second control ending points of these 2 splines, and these are joined. Next is ellipse. Just click on the ellipse, click on the center point, give an end point, major axis and then minor axis. So your ellipse is created. You can also define the constraint just by clicking on that. Let's say end point and vertical axis. Let's give it a value of 25. Then give a minor axis value, which is 20 itself. Next is our parabola. Parabola in CATIA is defined by focus. So let's define the focus, and then vertex point, then starting point, starting from here, then ending point. Let's give an ending point. So this is our parabola whose equation is x is equals to 4ay square. Next is hyperbola by focus. So let's define a focus point, and then vertex point, then again starting, then projection curvature, starting point, and then ending point. The vertex point on the hyperbola does not lie on the curve, which is the difference between a parabola and a hyperbola. As you can see, its vertex point was out of the curve on the horizon, which is a hyperbola projection. Next is conic. Conic requires two directions, and conic curve is tangent to those directions. So let's create the two different directions. One is horizontal, second, let's say, okay, let's have another try. Give a direction from horizontal and vertical. These are the two directions, and conic curve is automatically taken tangent to these two directions, as you can see here. So this is how a conic is made. You can also adjust its shape accordingly. Now let's create a straight line. So first is our line. Line is a simple segment joining 2 points, as you know, the starting point and then ending point. And this is just a simple line which was starting from a starting point and ending to another point. Next is infinite line. Infinite line is used to create infinite lengthed line. So it's our let's create, it was a horizontal line. You can also switch from to vertical line and an angle line also. Just click on this and give it an angle. Give a horizontal value of 0 0 0 and vertical value 0, and give an angle of 45. So that horizontal and vertical value was to give a detection point at 0, 0. Now let's create two circles and make a bitangent line. First tangent, second tangent, and this is a line which is bitangent to these two circles. Let's create a line segment. These are two lines, and now let's give an angle constraint to this. Let's say we are going to take an angle of 60 degrees, and we are going to make a line bisecting to these two lines. So just click on the bisecting line, click on the first line, click on the second line, and here we have a line which is bisecting to the angle segment of these two. And line can be created normal to a curve. So let's create a curve, and the line which is normal to a curve, as you can see here, this line is normal to the tangent of our curve. Next is axis. We can define axis by defining the end points, like to define a simple line, which it is also considered as a construction line. Now let's create a line segment and create a point by clicking. You can click anywhere to define a point, as you can see, anywhere in the space, also anywhere in the curve. Now the next method is to define is by coordinates. Let's give a horizontal and vertical coordinates to a point and click OK button. So here we have a point created at 10 and 20 distance of a previous point defined. The point which was defined previously is taken as an origin point for the next point. Let's try giving coordinates on the polar. Give a radius of 10, 0, 10 and angle of 45. So this is, now let's have a curve and a line, and equidistant points can be created having a regular interval. Just click on a curve and define number of points. Let's say we want to define 15 points and click OK button. So here we have 15 points on this circular segment. Also we can create the same thing with the line and click OK buttons. As you can zoom in here, these are the points defined at a regular interval on the line segment. So these all points are at a regular interval. Okay, let's create a line and another line which is intersecting, and let's create a point by intersection. So just click on the first line and second line, and a point has been created on an intersection location. This is the line by intersection. Next is projection point. So to project a point, we require a point. So let's create a point first to project on a line, and just click on a projection point. So just click on the point and then click on the line. So we can see that that point which we created has been projected on this curve. So here I'm going to conclude this tutorial too. Thanks for watching. Thanks for watching videos from CAT Desk head office. Thank you.